13.33.3 plus by 2 times 10 to the power 3x. Okay, so this is equal to minus 5 times 10 to the power 3 x squared. 2000, 1000. So 2 to 4000 minus 1000, 3000. Okay, so 2 plus 2. Okay, and then minus 200 plus by 133.3. Minus 200 plus 133.3. So it's equal to minus 66.7. Okay. So with that is our, so we realize that our shear force equation, bending moment equation, is a second order polynomial equation. Okay. Now I want to sketch the shear force and bending moment diagram now. Okay, I'm going to sketch it. So now we're going to sketch. Okay, so this is our shear force diagram. Okay, so this is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So this is our x. This is b. So the maximum value we found was 2000. So this is our 1000. This is our 2000. Okay, this is our minus 1000. And then we have our minus 2000 down here. Then our bending moment diagram. Okay, our bending moment diagram, I'm going to focus on the positive side. Can anyone tell me why I only focus on the positive in our bending moment diagram? Anyone? Can you recall? Oh, this is moment. Okay. Can anyone recall why the bending moment we only focus on the positive? Let me see the answer. No, I got no answer. I'll tell you why, okay? Very simple stuff. No need to memorize anything. Okay. So again, 0.1, 0, 0.2, 0.3, 0.4, 0.5, 0.6. Why we focus on the this is positive bending moment, this is negative bending moment. Okay. Why I don't know the numbers. Okay. When I'm doing this, I'm not looking at my paper. I'm forming the equation as it is. Okay. Why is that? Why I focus on the moment? Because if we were to look at the deformation pattern, okay, positive moment will deform, the deformation pattern will be a smiling face. Okay. Negative, the deformation pattern will be a sad face. Deformation pattern, not the mathematical equation. Okay. So now if we were to go back into our diagram, the deformation pattern we know will be a smiling face. Yes or no? Right. That's why I focus on the bending moment or on the positive side. So this is the deformation pattern. Actual deformation pattern. Okay. Right. So we're going to sketch. So if I have to label the points, this is point A. Okay. This is our point C. This is our point D. And this is our point B. Okay. So we know that if we look at at point A, we have 2000. Okay. And then at point C, right, we have at 1000. Okay. Now, is it a straight line or a curve? So if you look at our shear force equation, okay, so this is our shear force equation, right? It's minus 25 times 10 to the power 3 plus 2000. Okay. So we know minus means it's a set face. So this will be coming down set face. Okay. Then we look at our bending moment diagram. Okay, so a bending moment diagram is also a set phase, right? And moment at point at when at point A, okay, the moment is equal to 0. And then at point 2, we calculate equal to 333.333. Okay, so this is 100, 200, 300, 400, 8.2, 33.33 is somewhere around here. And if we were to look at the equation, okay, we look at the equation over here. It's a third order polynomial equation and it's set phase. So the equation will do like this. Okay. And then we will now plot between point 2 to point 4. Okay. So between point C to point D. So if we look at point C to point D, and we are going to look at this equation. Okay. This equation is a linear equation. Okay. It's a linear equation. So when x is equal to at point 3, it will touch 0. Okay. So it's going to be a straight line. Okay, it's going to be a straight line. And then from here, okay, we have not formed the equation because of symmetrical loading. It's going to end up this way. Okay. And then on the other diagram, on our bending moment diagram, it's going to be set phase, right? And it's going to be, we're going to find at 0.4. Okay, so we don't know the value. Okay, so we're going to substitute. Okay, we're going to substitute. So this is our equation number 3. This is our equation number 4. We're going to substitute equation number 4 when x is equal to 0.3. Okay, so m at 0.3. I'll tell you why I picked 0.3 for a reason. Okay, so minus 5 times 10 to the power 3 multiplied by 0.3 plus by 3000 squared multiplied by 0.3 minus 66.7. Okay, so minus 5 power 3 times by 0.3 times by 0.3 plus by 3000 times by 0.3 minus by 66.7. So it's equal to my 383.3. Let me do it again. Okay, minus 5 power 3 times by 0.3 times by 0.3 plus by 300 times by 3000. Come on, times by 0.3 minus by 66.7. It's 383. So 383 is somewhere around. It's slightly higher. Okay, at this point, and then it'll come down again. Okay, so if we were to substitute equation 4 where x is equal to 0.4, okay, so m 0.4, so you have minus 5 times 10 to the power 3 times by 0.4 squared plus by 3000 multiplied by 0.4 minus 66.7. It should be lower than 33.3. It should be the same like at 0.2. Okay, so minus 5 power 3 times by 0.4 squared plus by 3000 times by 0.4 minus by 66.7 is equal to 333.3. Okay, exactly down here. And then you will have a set phase coming down. Okay, what I want to highlight is this. Okay, I know the fact y'all will know this already. When the so there's a possibility. Okay, what did we learn down here? I think this is the most important thing. So when number one, when shear force is equal to 0, okay, there is a possibility. Okay, there is a possible, not always, because sometimes you can have shear force intersecting the zero line at multiple places. You have to check. There's a possibility that bending moment will be maximum. Okay, that's the first one. Then the second thing that you observe is what? Okay, so I want you to see this. From 0 to 0.3, the magnitude is positive, right? For the shear force. From 0.3 to 0.6, the magnitude is what? Negative, right? If you look at the bending moment diagram, okay, the tangent at any point, if I would draw a tangent, come on, Eugene, choose a different color. If I would draw the tangent, right, at any point, right, the gradient is positive, right? And then if you look at 0.3 to 0.6, where you see your bending moment diagram, the gradient is always what? Negative. Can you see that? So the gradient is negative, right? So there's a trend down here. You can see down here there's a trend. So positive magnitude in shear force, or positive shear force magnitude will give you, okay, will be equivalent to positive bending moment gradient. And likewise, if it's negative shear force magnitude, you got negative bending moment gradient. Okay, so this is, I think, a very quick recall regarding your shear force and bending moment. Okay, regarding your shear force and bending moment. And that's all I'm going to teach now. Okay, study hard for this weekend. Make sure you know how to do all your homework. I think more important is to make sure that you write a summary sheet. Okay, summary sheet, what I mean, like the most important thing is the shear force diagram. I mean, sorry, the shearing stress, right? The 5 rules. Okay, that is your summary sheet and how to apply them. Okay, and you have to make sure you do your homework. If that's the case, I'm going to stop here today, and I'll see you guys on Monday morning, 8:30, either face to face or online. Does not bother me at all. Have a great weekend. Study hard just for this weekend. Okay, study hard.
Eugene, you have a U and an N. What does that mean?
Huh? Wait.